Morgan is doing this fellowship on agentic coding, and I produced a paper recently on agentic coding where you just, I was interrogating the agent and asking it very pointed questions, and then putting together different models from that. And so that's all
Well,
kind of I think a lot of people are experimenting with that. And
yeah, just I'm still refining the what had started as the hypergraph library benchmark. Just been adding to that, and like yeah, and trying to. I'm seeing now that even though there's a couple groups that have replicated Anthrobots, um, nobody's actually replicated Xenobots,
hmm,
or at least not that I've found. And yeah, so just thinking about what kind of, again, we'd love to be doing um, something at Biopunk. Um, that like can we use the wet lab to actually do some interesting science that and Levin's work in particular would be um I think is interestingly accessible as well as kind of frontier, you know um so trying to put together resources, and we'll um, and have some sort of just like summary white paper on that in terms of if that's something accessible. So
yeah.
yeah,
So
uh, uh,
yeah. Uh,
try,
what's the difference between an Anthrobot and a Xenobot? Remind me.
so Xenobots are using Xenopus,
Okay.
as the Anthrobots are actually human epithelial cells.
Oh yeah.
So yeah. And like all of these um I was kind of like trying to take some of what anatomical compiler work and trying to apply it to Xenopus in terms of like, you know, are there things we could do that, for instance, using Davies' synthetic morphology kind of framework for how to kind of like what are the main classes of modules, how to kind of direct the form of the organism in ways that would be more Xenobot, or like we could like obviously one is just working on the ciliated the ciliated features, but like this is one of the areas where they were actually doing simulations to make a biobot prediction, right?
Yeah.
And like could you do something similar? But
Right.
like stick with Xenopus. That's easier and less expensive for us to work with. And but still have something useful, or like still be working on like, can you control form, and with form get or make function predictions, right?
Yeah. That's good. Yeah, I look forward to seeing more on that. And how that comes out, because I know a lot of the work is, you know, the key is in replicating it. It isn't just in proposing it. So like a lot of people
Yeah.
propose things.
Yeah. So I want to check. I mean, so I want to check in on Kriegeman's. So it was like the postdoc that was working on this. He's got a new lab at Northwestern, um, and seems to be focused on continuing this. So, like, I think his website is xenobus.group,
Okay.
or maybe it's like xenobot.group or something. Anyway, um, uh, and um, and then yeah, two groups have supposedly replicated the Anthrobots, which is nice, because this is one of the complaints that people have had, or at least one of the complaints I've heard from some is like, Levin does these experiments and then nobody actually checks them, or nobody's able to replicate them
Right,
or
right.
something. you know and uh, I just wonder how much it's just like nobody sees. I mean, they're not very um, I just remember this one group saying, like, well, if Levin's work is so good, then why has he got no spin-off companies, successful spin-off companies? I was like, I'm not sure that's the measure that you think it is.
Yeah.
I sort of, like, anyway.
Right,
Um,
right.
uh, I don't know if like, you know, would you say that George Church has had a lot of good spin-off companies?
Well, yeah, there are a couple of
like,
exceptions, but for the
like some, yeah. Well, some of those are spectacularly
yeah,
unsuccessful. Is what I was gonna say. I was just like, sometimes people can just suck up a lot of VC money and
yeah,
actually, make a lot of headlines, but they don't actually make anything. Um, anyway, uh, yeah. So it's I'll post it. Biopunk doesn't have an org, but I want to. Um, I'm gonna post this on make an org and post this and see if we can get some
yeah,
actual students working on this.
yeah. That would be great. Sounds great. Yeah, I think the
Yeah.
things about well, a lot of biology experiments aren't usually in the realm of I mean, they're supposed to be replicable, but it's like, what's
Yes.
the sort of the baseline for replication, or what is the standard? So like a lot of times it's like you have to have a dedicated lab, and you have to follow protocol just right, and and then of course with a lot of molecular biology experiments, they work in the hands of certain people, or sometimes they work and they don't work in other when you try to replicate it, because of many factors that
Exactly.
we
Yeah.
don't.
Yeah.
And so that's that, and you can't, but with science you can't necessarily uh automatically just create a process where you can reliably replicate it in the engineering sense, right? So
Yeah. Yeah.
you in engineering we create a proof of concept and then scale that up, and in biology oftentimes we're not doing that. We're trying to find knowledge. We do an experiment, it works, and it might be replicable, but the results are kind of what matters. But also, we'd like to replicate it if possible. And if we have the tool, if we can do that, that would be great. But it's not I think there's been way too much emphasis put on replication as a standard of success or failure, because a lot of times we'll do things and we know that they work because of other evidence. We know, for example, that something should work. Sometimes we do experiments because they should work, right? We don't just do experiments out of thin air. We kind of come to the conclusion that this experiment should be done because these other things have been shown to be the case. So let's do this. And if we can get a positive result, then that supports the idea. And if you can replicate it, great. If not, well, we got it to work once. So, and so that's a fundamentally different view of how to proceed, and I think, people focus way too much on kind of the engineering slash VC approach to this, which is to say, you have to have everything standardized, and these sort of bricks that you stack together. And if you're not doing that, you're just kind of engaged in failure. That's not really the way to view a lot of developmental biology. You think even today, where we have a lot of tools that we can use to like manipulate things and standardize things that we still don't have. We're not even close to the engineering slash VC vision there.
Mm, yeah, yeah. I mean, yeah, there was definitely a certain amount of I think people are still working on getting their reporting good enough so that it, that there was a reproducibility problem just because there was kind of like a lack of proper documentation.
Right.
So like what you see in terms of groups really trying to share protocols more completely.
Yeah. Well, the
Trying to
protocols.
find a I'm trying to find a diplomatic way of but you know what I'm talking about.
Right. Oh yeah. Yeah.
Yeah, like that was a kind of a real problem. And
Oh yeah. Yeah.
uh and I think, I mean, I also think of um that Marilyn Lancaster talk. She gave something that was like, it wasn't a formal, I mean, it wasn't an academic talk, it was kind of like a showing off to like Cambridge research.
Hmm.
um but she had a a, a section of it devoted to just why we're not able to replicate each other's organized research. like like different groups are not able to replicate other groups work.
Right. Yeah.
And like what's missing. um and it did seem to be that like there's actually just a lot of there's a lot of methodological differences that still aren't really being reported.
Yeah.
um, um, but yeah, it's the translational and the kind of like like this like every PI needs to be a startup founder is not a direction that I think is helpful.
Yeah.
Like if anything, I feel like that makes the reporting like seem like a bigger burden,
Right.
or like a not a burden, but like you're potentially giving away the secret sauce.
Right.
um it's like, yeah, I mean, we just had a group come through, saying, again, these are biotech startups, and they're just basically telling everybody in the lab, like, don't publish, because agents will just pick up your work. And you know um,
Yeah.
yeah, and it's just like I'm listening to it, and just like I don't want to. Yeah, I was not exactly happy with that particular. Uh, yeah, anyway,
Yeah.
you can see the tension there.
Right. Right.